Hello everyone, welcome back. Let's talk about another medium problem on Leetcode today. Binary tree label order traversal, Leetcode 102. In this problem, we are given root of a binary tree and we have to return the label order traversal of its nodes values, that is traversing the nodes from left to right, label by label. Then in example 1, for the given tree, there are three labels, label 0, 1 and 2, and the output has three lists. We start from the root node at label 0 and add it to the first list. Then we move to label 1 where we go from left to right and add the nodes 9 and 20 to form another list. And finally we move to the label 2, again traversing from left to right, and add the nodes 15 and 7 to the third list. And once we are done, we return these three lists as our answer. Now in terms of solutions, since we are going through the tree label by label, we need to apply the breadth first search or BFS. I have covered BFS earlier, so if you want to learn it or revise it, please check out the I button. I have also covered label order traversal, but with a difference. Previously, we returned a single list for the traversal. However, here we are returning a list of lists, with each list representing the nodes at a particular label. Please check the I button if you want to watch that video. This traversal method is different from depth first or DFS traversals on trees, namely in order, pre-order and post-order. As it is BFS, we will be using queue and add the root node to the queue. For example, here we add the root node 3 for the current example. And next we need to process each level of the tree, and the question is how can we separate the nodes by labels. For that, let's look at the BFS a bit closely. Initially we add root node to the queue to start the BFS. This label only has one node which matches the queue size. Then we dequeue it and add its children 9 and 20 to the queue. The nodes on this label are 2, which again match the queue size. So we can use queue size to get the number of nodes at the current level, and before dequeuing and processing the nodes at given level, we can get the queue size, and this allows us to process all the nodes at the current level together and add them to a sublist for that level. If these nodes have children, then we add them to the queue and they will be processed in the next level, and we repeat this process until queue becomes empty. Now let's see this in action. So current queue size is 1. So that means we have to process one node for this level. So we dequeue 3, visit it, that is we process it by adding it to the current level list and add its children 9 and 20 to the queue. Now we are done with this level. So we add this answer sublist to the answer list. Then we process the label 1. So this time the queue size is equal to 2. So that means now we have to process two nodes together. So first we dequeue 9 and visit it by adding it to the answer sublist. And since 9 doesn't have any children, we don't add anything back to the queue. Then we dequeue 20. We visit it by adding it to our answer sublist and add its children 15 and 7 back to the queue. Now we are done with label 1. So we add this answer sublist to the answer list. Now the queue size is again 2. So we again process the two nodes together. So first we dequeue 15. We visit it by adding it to our answer sublist. And since it doesn't have any children, we dequeue next node from the queue, and that is node 7. So we visit it by adding it to our answer sublist. And now we are done with label 2 as well. So we add this answer sublist to our answer list. And now since the queue is empty, we will return this answer list containing the nodes label by label. Now let's jump into the code part. First let's initialize list of integers called answer to store the label order traversal result. If the root is null, that is tree is empty, we will return the empty answer list. Otherwise, let's initialize queue to perform label order or BFS traversal. We can use linked list implementation in Java for that. Let's add root node to the queue. Now we will start the BFS. So while queue is not empty, we will create a list to store the values of the nodes at the current level. Also, get the current size of the queue, indicating number of nodes at the current level. Now, for each node at the current level, we will dequeue the node, add the node value to the current level list, and then if it has children, we should unqueue them to the queue, starting with the left child. So if the current node is left child, we add it to the queue. Similarly, if current node is right child, we add it to the queue as well. And once we are done with this level, we will add current level list to our answer list. And finally, once the queue is empty, we are done with BFS, so we will return our answer list. Now let's submit this code. Cool. In terms of time complexity, it will be O of n, where n is number of nodes in the tree. Because we are traversing through each node only once by adding it to the queue and then removing it. And in terms of space complexity, it will be O of n, because we are storing the labels in the queue as well as current label list and also in the answer list. And in the worst case, for example, for the completely filled binary tree will contain n by 2 nodes, and at any point queue is storing the nodes from at most 2 labels, which is still proportional to n. So the space complexity is O of n. So that's all for this video. I hope this video was useful to you. If it was, please give it a thumbs up and share it with others who might benefit from it. If you haven't subscribed the channel yet, make sure to hit the subscribe button and turn on the notification bell so that you never miss an update. Your support helps me create more content like this. If you have any questions or suggestions, feel free to leave them in the comments below. Thanks for watching and see you in the next one.